Welcome back. Okay, this is a couple of days later. I had to pack everything up and do a couple of service jobs. So I had to remove all this and put it aside so I actually can do some disassembly and whatnot here in this section. Okay, well, I have now gotten the motor start capacitor wired up and my little 3-pole terminal block here, which I fit on these. I've got the gears all in and greased. And so that's all happening, everything's been bolted up and everything in that regards. And I have got all the wiring done and the limit switches are on and the activators and everything. I've wired them. I've got this is all new wiring all the way through, by the way. Pot has been refurbished and has been rewired, and I've got everything sitting all in there. So I just thought I'd show you this. And I'm going to assemble all this and get things happening. Oh, flare out. So yeah, so that's where we're up to. So I shall be back shortly. What I might do is I'm going to try and see if I can feed all these wires through the holes they're meant to go through. Okay, let's put the potentiometer wires through this hole first. And we're going to put the... I normally cut these a bit long so I can actually physically get the wiring done, and because I do change things around a bit. This motor start capacitor is normally attached to here, which means it's actually very hard to get this top plate off and workable. So I wire it up differently, and also I'm wiring into the input side, and I've already cut one leg off which is not needed, and I just have the other legs ready to go. And wired up, and I leave these ones long and loop them down so we actually can physically lift this off without having to physically remove the motor start capacitor. Every time you want to service the body or take the top off, you can actually lift it right up, and then you can unsolder it from the little terminal block down the bottom here. But at least you can lift it up and lift it off and get things out. So because I'd wire things different, I set things up differently. This shaft being fixed, you normally remove the shaft to get that gear out. Well, I can't put this whole thing down yet until this assembly is in the guts, because I've got to put the limit ring in. Has got to go in first because the gear goes over top of it. It goes up in here. So the gear goes in here. So you've got to put everything in together first in a certain order. So I'm just going to. I've got to go and press this all into position because it's a nice tight fit. So. Which I'll be back shortly. Okay, forgot to mention that I'm going to be wiring up everything first. I'm going to leave this a bit loose at the present moment, but I'm going to wire the socket on first, which is next, because this can be put in from the inside out, as I probably mentioned before in videos. That's why I like these, which means you can take the whole thing out. Haven't got to unsolder anything or desolder anything. You can just physically test it on the bench, push it back through the hole, locate it, put the nut back on again, and you're done. So I'm going to go and pre-wire all this mess, which you can't see, pre-wire all this mess into the socket. So that's done, and I shall be back. Rightio, I have wired everything up. It's still a bit loose at the present moment. As I said, the socket is already wired, so now I can actually physically can drop it in. I've got to do some more testing and whatnot first, but I'm going to drop it in, and I've got to put the brake and everything in first, but get that all done. So I'll be doing all that next, and then I'll be putting the motor assembly in, and we'll be moving forward. So okay, so onto the brake we go. Right. Okay, just a quick update. Well, I now have the brake assembly installed with the actual retainers. Stop the wedges coming in too far. Let's see these things here, little wing things. I've got all the clips and everything in. It's still floating around because it hasn't got the base plate on. There's looking from the bottom. So I just have to put the actual two. I've got the two spades here. This makes it easier than having it all wired up. It's just like, plus these wires on this one were actually very badly damaged, and one was melted and one was cut back. I think somewhere along the line someone must have jammed it in somewhere, and so I had to cut everything back really short to get into my socket, and had to put the socket in a new position, and the new position is going to work out better, but it just makes it a little bit harder to get the actual the bits in, but that's okay. We work with that. We move forward, and so I'm going to drop the actual motor assembly in and move forward. We shall catch you soon. Okay, I have now got the motor assembly installed, and basically all I've got to do now is the limit ring has got to go in, but I'm going to have to pre-grease all this, and then I can put the this gear in. I'll turn this upside down a little bit so you actually can see up inside. The wiring is all out of the road. I can move this around without it. The actual brake wedge assembly, the bits that move actually hitting anything. So there we go. So that's all good. And the beauty of having this socket in here, you actually can just lean it out of the road and you can undo it, and you actually can move it around in here and whatnot. So yeah, so at least you can get it out from here, from the very bottom, unplug the actual solenoid and pull the top out and leave the solenoid in there. So that's how I like to do this, and it works really, really well. Okay, well, I'm going to go and put the limit ring in and the top gear and bolt this top section down with the little plate, and I shall be back. Okay, now have the flare out. Now have the limit ring in. It's all bolted down. So yeah, it's moving forward. I've even put my north mark on here. I'll be projecting that down later on, and I'll be continuing on. So we shall catch you soon. I'm just going to be doing the bottom bearing ring, brake wedge housing. It's got to go on. You've got to fiddle around trying to get the wedges to align and everything. But yep, it's all moving forward. Catch you soon. Okay, I've got all the primary alignment done and checked that everything works, and basically I've got the top bearings in, so it's all ready to go in a sense. So basically I'm going to grab the top housing and see if I can drop it. Okay, or not drop it, hopefully don't drop it. I'll line up my marks on here with the marks on the housing and everything. And working behind the camera doing this is pretty hard, so we just drop him on, line up the gear, looks like I'm a little bit out. I'll have to work at that. Okay, we shall get back to you shortly. I have already pre-greased the bottom track when I do the top one, and I've loaded up the bearings into the bottom track. When you're putting the bottom bearing ring / brake housing on these things, you must push the actual socket inside of it. So basically you can still hold it from up the top here and just get it to go in a bit, just so it's not, whoops, a bit too far. That was one turn too many. Just in a little bit I want. There we are, hold in place. Okay, we are going to pull the brake back to the middle, the wedge I should say, brake solenoid back to the middle. So the wedges are vertical because it's actually relative to that. Better spin him around again too as well. Oh, okay, we'll leave that out then. Wants to be a pain, we'll leave it out. Bring it around to our alignment marks. Stand up there. Turn him over. Drop him over the top. Align our alignment marks. What we've got to do now is we've got to push the brake wedges, both of them, in. And then we slide them down. And it's actually engaged again already. Look at that. All the way down. Okay, I'm going to bolt it up and I shall be back. Okay, we're back. Bearing ring / brake housing is on, and I've also made up a new seal for the bottom of this, as this rotator never had one, and I don't have any in stock. I've made this up out of 2 O-rings. This one's 7mm and this one is 2.5, I think it is. And basically they're just glued in a few places around here to hold them together. This bigger one is exactly the right size and it holds itself in place, but I did put a couple of drops of glue just to hold it in place, make sure it doesn't move. I also forgot to mention that I have installed, we can't see them, recoil inserts into these four mounting holes for the base plate. These had self tappers and they're a terrible bloody thing, so I drill them out and install Sensus materials. Tapping into 3mm on this casting is pretty bloody terrible to do, so basically I've done that, and then I use a little countersunk 3mm screw, and I also just countersunk the top of this just ever so slightly, just so it sits down a bit lower. It does sit pretty, flare out. So it does sit pretty close. So I'm going to put the base plate on, go and do a few tests, and then I'll be back and we'll show you the whole lot running. We are basically done. So I'll just a bit of a spin around. So that's all in. There we go. Right, I'm going to put the base plate on and I'll be back. Okay, the rotator is now all together. So let's take you for a bit of a run through, or run around I should say, showing it all done. I've got my label, there we go, well, that's flared out, sorry about that. Flared out, so yeah, that's been labelled at the bottom, all the screws are in, so that's all good, everything's happening there. So, as I mentioned at the beginning of the video, I'm going to show you everything that I've done to the actual controller. So I am going to stop right here and I'm going to undo all the bits and pieces in the controller, and I shall be back to show you what has been done to this controller. I'll be back shortly. Okay, we're back. Righto. Now to show you what I've done to the insides and the outsides of this controller. So basically it is a standard controller from Emotator. So basically it's just a left and right action, flaring out. Left and right action with a lift to lock feature. We have the power switch here, and the LED here is to indicate the brake action, which I'll describe later on. As I may or may not mention, the chassis was upgraded, and then I had it re-zinc plated, along with the backing plate. It was done, and a new label was put on it. So the back panel, the modifications on the back panel, the upgrades I should say, a fused IEC socket, earth bolt, and a 8-pin cinch plug with a cover plate. And if I get the light to shine in the right direction, you'll see that all the pinouts are numbered on here. So 1357, 2468. And I've also shortened, as you can see here, I've shortened the post on the potentiometer for display adjustment. They're way too long, and I want to try and keep everything in line, no longer than the actual earth bolt comes out the back. So you may notice that there's a PC board sitting in here, and the standard board is sitting there. So this is my brake delay PCB for the 100 volt solenoids of the Emotators, 1102s and 1103s. So basically two capacitors I can select. We can't see it anyway, selecting it down in here. I can select the delay time from 3 to 5 seconds. Down in here there's a little, we can't see it, there's a little jumper pin thing. Just pull it off and put it on the next one. No soldering necessary. So it's just a very basic board, but it's all got screw terminal blocks on it. So this is one of my newer ones. I've had a few designs of this, so this is the latest design. So basically that's what's happening there. The display was totally stripped down and upgraded, and I've totally refurbished the pot, stripped it down and refurbished the pot. Over here, I forgot to mention, on the front panel I've replaced the actual display indicator, display assembly I should say. The original display for these, as in the direction display, is a piece of plastic, thin plastic, which they get really opaque and worn out over time. So I've actually replaced it with a hard plastic as opposed to a soft plastic, and a whole new assembly and a backing from a different rotator controller that I had here. And I've also put in a surround around here because the sides do not quite match up, and also there's LEDs, which I'll show you shortly, in each corner. So basically, we shall look at that. So in the back of the display, I have got one of my Y-LED boards, which has been slightly modified and having little pin out, little terminal blocks here to run off to the 2 LEDs per plug. And as you can see here, there's one little 3mm white LED there. There is one there, and there's also one here and one there. This backing is a steel backing, and is the assembly from the other controller I did mention before. I didn't mention what brand, I'm not going to mention that, but some people might know, the rotators might notice this. So basically inside there's terminal block for the power to come in through the back, and there's a little terminal block which I screw on prior to putting it in. And basically it has a brand spanking new made in Australia transformer. So basically it's made by Star Delta, which you can't quite see, it says Star down in here, Star Delta. So yeah, that's been put into there. What else have I done? Probably can't see it, but the ISS socket I use, and where the original tag was bent up to hold the original fuse holder, which is like a death trap, the bloody thing, I've actually bent it down and I've actually used it as my earth post. So when you're looking there, you'll see a bolt and you'll see the tab match up inside. So I've used that actually holds this in place with all the 2 screws here, but I get instant earth straight away onto the chassis. That means I can reuse that particular strap that was actually bent straight up, which held the original fuse holder, which was totally exposed. That's why I don't like them. So what else has been done here? Yeah, so I had to cut away and do things up on the top of this because it was all steel and this backing for the display. So that's all been done and everything. So yeah, yeah. So it has I should actually pull this off. It has a clear lens over top. It has the lettering, or numbers I should say, for the scale actually on it, and the LEDs are actually got a small hole, and they're actually shining into the display, and I've actually got a reflector on each of the corners, which you can't see of course, to direct all the light into the lens. And around the edge of the lens, you can't see it because I've blocked it off. I probably can see it up here just about. I've put a white, I use white out, and I white around all around the edge of the display to contain the light and reflect the light back into the lens, so you don't need as much in the LED department to illuminate it. So there we go. So yeah, and that's the brake delay, which is driven by off the PC board here. So basically everything is driven off this. So yeah, I think that's about all. 8-pin cinch plug, all wire. Everything's been totally rewired in here, so it's all new wiring. The only thing that's not new wiring is the ones from for today's PCB, but all the rest of the wiring is all new. So there you go. Rightio, well, I think we're up to date now. We shall put this all back together again, like that, and I shall put this all back together, and then we'll be back and I'll show this whole thing working. Back soon. Okay, here we are. I've just set everything up to save a bit of time on the video because the video is getting pretty long. So basically I'm just going to quickly show you this all working, and I'll show you the LEDs when I turn it on. The LEDs illuminating the display when I turn it on. So I'm moving forward and we'll see if we can see it come to life and show that it actually physically working. So let me turn it on. There's our display illuminated. At the same time, the little LED down here, which you can't see. as usual in a video it flickers, but it doesn't flicker when on your eyes normally. So there we are. It's actually it's display is on. The display is actually adjustable inside because my wire LEDs have a trim pot on them to physically adjust the brightness. So basically we're going to take it through for a quick run, and then we'll be out of here. We'll be all done. So, okay, so let's go. So we'll go around to the left to start with. You'll hear the brake disengage, and basically it will rotate, and then when I release it will coast, and then the brake will engage. Do that again. You hear the brake engage. Not as noisy as some other rotators, but so we'll drive around. Fairly slow rotator. These are 100. Oh, I can't remember what the speed of this is time-wise at the top of my head. Which is never know. That was in lock mode for a second. So basically, you can do, as I mentioned before, manual like that, or there's our brake engaging again, or we can lift it up like that, and it goes in the lock mode. So we don't have to have a hand on it. We don't want to stop that. Just do that. We'll just go right around to south. Limit switches will take over when it gets to south, so we can't hurt the rotator. Oh, it looks like there we are, a bit better. So there we are. A little bit of overlap, about 5 degrees thereabouts. And you see the brake. Well, I should actually. You probably see the light go out. Maybe it's only a little baby LED. It's only just an indicator, and it comes back on again. So basically, there we go. So let's take it for a run around the other way. We'll just do a complete run around. They're not the fastest rotator, but they've got a reasonable rotation torque. These things. It's all on the spec sheet for these. So it's all good. So we'll just let this go right away round. Just try and save some time on this video. And being they're so slow, we don't want to stop it too many times. So we'll just keep going right around. What else have I done? Oh yeah, I haven't mentioned this in this video. The plug on these is an LTW Amphenol snap lock type locking plug socket arrangement. They are not screw on. So basically, you engage it, the tabs, and you turn it basically half a turn, and it gets resistance, and then it goes snap and locks in place by little tabs that actually lock it in place. You don't need to do any more. These are also got glands in the back, glands in the middle section, and an O-ring in the base of this here. So you don't need to put boots and silicon and all this stuff over them as well. So basically, they are an IP67 rated plug socket. I'll probably show you. There we are, pulled apart. There's a gland in there. And there's also an O-ring sitting in here to seal against the inside, nearly up to south. I'll go to south before I continue on here. We'll go a bit overlap. We'll stop, and then we'll let the brake engage, and then we'll drive it back. Wrong way. So in the back of these, there is a gland in here. We can't just see it. Try and get it out. That grips the actual cable and seals the cable back section. I can't get it out. So basically, I like these plugs. Unless there's maybe some better plugs around, but these ones fit into these openings without having to do any major filling up and all sorts of stuff. So yeah, and of course, if you know anything about cinch plugs, this is basically the same sort of thing that was used on high gains and stuff. I've got a few of these in stock now. So this is 8-pin version. I've also got 6-pin versions. So yeah, easy to wire, and we'll just stop this now. We'll get up. I'm going to stop it at north. There we go, we're back to north again. Brakes engaged. We are done, dusted, everything is finished, and now I can get this thing up for sale. We shall see you in the next project. Catch up, bye.